Okay, hi everyone. This is section 11.2 from your textbook, and we're going to look at how we solve simple problems using ratio. For your first task, please can you pause the video and complete the 3 questions that are on the screen. When you're done, replay the video and I'll be going through the solutions with you. Okay, so hopefully, I'm just going to put up the answers. Hopefully question 1 you didn't need any help with, okay? You had to just be working out how to fill in the blanks. What do I times 2 by to get me to 100? Well, I times it by 50. So I'm not going to go through each of those answers. Okay, I will go through A and B for question 2, just in case you're not sure how to multiply by 10 and 100. And I'll just remind you of how you do that. Okay, so 2A. You've got 1.5 multiplied by 10. When you multiply by 10, you're moving the decimal 1 place to the right. Okay, so it's moving 1 place to the right because it's getting 10 times bigger, the number. And that gives you 15. For part B, you have 2.45 multiplied by 100. Okay, when you're multiplying by 100, you move your decimal point 2 places to the right because it's getting 100 times bigger. So your answer to this part should be 245, okay? Please make sure you remember that. And likewise, when you divide, it's going to go in the other direction. It's going to go to the left because your number's getting smaller. Okay? So for question 3, I'm only going to go through 2 of these because we did it in yesterday's lesson. So this should be just a refresh, finding your HCF of pairs of numbers, okay? So they wanted the highest common factor of 24 and 30. So first you need to find your factor pairs of 24. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. And then your factor pairs for 30. So you should have 1 and 30, 2 and 15, 3 and 10, and then 5 and 6. Okay, then you look at the highest number that's in both lists. In this case, it's going to be 6. So your HCF is 6. Okay, I'll do it for part B as well, and then you can just look at the answers for the rest. Okay, I hope that's enough so that you understand. So part B, pairs of numbers we have 35 and 49. To start finding the factor pairs of 49, which pairs of numbers multiply together to make 35. 1 and 35. It's not an even number, so 2 is not a factor. 3 isn't a factor, it's not in the 3 times table. 4 is not a factor, but 5 is a factor. 5 and 7 make 35. Then you get 6. 6 isn't a factor, and then you're back round to 7. So you know you've finished there, and they're all the factor pairs for 35. 49, 1 and 49. Not even, so 2 isn't, 3 isn't, 4 isn't, 5 isn't, 6 isn't, 7 is. 7 and 7. Okay, make 49. So they're your factor pairs. The highest number in both lists is 7. So your HCF is 7. Okay? Moving on to the main part of the lesson now. There's an example that they've given you there. I'm going to walk through that example on the split screen as well so you can see more practically how you do it. So it says, to make orange paint, Maria mixes yellow paint with red paint in the ratio 3 to 1. So the first thing I'm going to do is I'm going to write yellow to red. That's the order it's been given, so that's the order of the ratio. In the ratio 3 to 1. So I've just written out so far the information the question's given me. It then says she uses 4 tins of red paint, so how many tins of yellow paint does she use? Write down the ratio and use Y for yellow and R for red. That's just a step. So we've already done that. So we're stopping there at 4. She uses 4 tins of red paint. So where I've got red, I'm going to write 4. This is like the opposite to simplifying, okay? I'm going to work out how do I get from the part in my ratio to the number of tins that she's used, so 2 to 4. How do I get from 1 to 4? I multiply by 4. 1 times 4 gets me to 4. So I need to do the same to the yellow ratio to find out how many tins of yellow paint she would use for her mixture. Okay? 3 times by 4 is 12. Therefore, those 3 dots mean therefore, she's going to use 12 yellow tins. Okay? So it's just a case of comparing it to the original ratio or to the simplified ratio you've been given and working out how you get to the number of tins that she used. Okay, so back to the slides. If you could now please have a go at the 2 questions on the board, or on the screen rather, not on the board. And for question 4, no calculator please. And question 5, you can use a calculator. So please pause the video and then come back once you've finished and you're ready to go through the solution. Okay, so I've put the answers up on the screen there, but I'm also going to go through them now just so I can explain them further to you. So question 4 first. Question 4 says, the ratio of oyster sauce to fish sauce in the stir-fry recipe is 2 to 1. So again, first thing I'm going to do, oyster to fish, 2 to 1. The order they give it is the order that belongs to in the ratio. Claire uses 5 tablespoons of fish sauce. So where the fish is, I'm going to write 5. I don't know the ratio for the oyster yet. That's what I'm trying to work out. So how many tablespoons of oyster sauce does she use? The first thing I need to do, compare. How do I get from 1 to 5? I multiplied by 5. Therefore, I need to do the same thing for the oyster sauce. Multiply this by 5. And she's therefore going to use 10 tablespoons of oyster sauce. Okay, so it's just comparing it to your simplified ratio. Question 5 says, Thomas makes a model of the Eiffel Tower using a ratio of 1 to 1,280. The height of his model is 250 millimeters. What is the height of the Eiffel Tower in meters? Okay, so model to real is 1 to 1,280. Okay, that's his ratio. The height of his model is 250 millimeters rather. Okay, so it's 250 millimeters here, and we don't know what goes here yet. Okay, so the first thing, what do I do to get from 1 to 250? Well, I multiply by 250. So I need to do the same thing to get the height of the Eiffel Tower in millimeters, though this is going to be, remember his model's in millimeters. So I'm going to times this by 250. Remember, you could use your calculator, and that will get me to 320,000. Okay, that's 320,000 millimeters. But the question has asked for your answer in meters. Now, hopefully one of the things that you know is there's 1,000 millimeters in 1 meter. Okay, so we needed to divide our answer by 1,000. So 320,000 divided by 1,000 to get our answer from millimeters to meters, and then you'll get 320 meters. Okay, and that's the end for that question. Well done if you got that. If you got to this part and you weren't sure for your conversion, remember they're the sorts of things you need to know. You need to learn that there's 1,000 millimeters in a meter. Okay, so on to the next part. So this is the next example. Again, I'm going to leave my split screen on so that I can go through the example with you on the screen. So, the key point you've been given there says ratios in their simplest form only have whole numbers. Sometimes you may be given ratios that have got decimals. You can't have, that's not its simplest form. To be in its simplest form, it must be a whole number. So in the example you've been given, it says write 1.5 to 8 as a whole number ratio in its simplest form. So we need to get that into a ratio in its simplest form. Now, in order to get rid of this decimal number, I'm going to times both sides. You have to do the same to both sides so it stays the same ratio. I'm going to multiply it by 10. And the reason I multiply it by 10 is because I know when I multiply by 10, it's going to move my decimal one place to the right and therefore get rid of my decimal. So I'm going to times both sides by 10, and that leaves me with 15 to 80 as my ratio. Okay, it's still the same, it's just not simplified. Okay, I've multiplied it by 10. Same ratio, just without the decimal now. Okay, now I want to simplify it. As this number ends in 5 and this number ends in 0, I know that they're both going to be divisible by 5. So I'm going to divide both sides by 5 to try and simplify my ratio. Okay, that's going to leave me with 3 to 16. And now they don't have any other common factors, so I can't simplify that anymore. That's just as simple as it can be, okay? 5 was the HCF of 15 and 80 in that case, okay? So 3 to 16 is now 1.5 to 8 in its simplest form. Okay, you couldn't have that. The other way you could have done this one is you could have just times it by 2, because timesing it by 2 would have got rid of the decimal, but it's better habit to get into multiplying by 10 first to eliminate the decimal and then simplifying, because you can't always find a number that is easy to multiply it by otherwise. Okay, so that's your example. Now there are some questions there that I'm just going to put up on the big screen for you to have a go. So please pause the video, have a go at the 2 questions on the screen, and as usual when you're done, please return to the video and I will go through the solutions with you. Okay, so question 6 first. So question 6 says, write each ratio as a whole number ratio in its simplest form. Okay, so start with part A. We have 0.4 to 6 as our ratio. As before, I'm going to multiply both sides by 10 to get rid of my decimal number there, and I'll be left with the ratio, the equivalent ratio of 4 to 60. I now need to simplify, because they're both even numbers, so I know they're at least divisible by 2 in order to get it into its simplest form as the question's asking. Okay, but I know the highest common factor of 4 and 60 is 4, so I'm going to divide both sides by 4, and that leaves me with 1 to 15 as my simplified ratio for part A. Part B, you've been given 3.5 to 4.2. Okay, in this case, both sides have got decimal numbers. Multiplying by 10 is enough to eliminate the decimal on both sides. So multiply both by 10, you have 35 to 42. You now need to look for your highest common factor. I know that both of those numbers are in the 7 times tables. So I'm going to divide both sides by 7 in order to simplify, and that will get me 5 to 6. And that's in its simplest form because 7 was its highest common factor. Part C, you have 45 to 13.5. I need to multiply by 10 to eliminate the decimal. There's only a decimal on one side, so that's fine. Multiply by 10 leaves me with 450 to 135. Okay? If you're not going to find the highest common factor, you should start then at least dividing by 5, because you know this one ends in 0, this one ends in 5, so they're both divisible by 5. So if I start by dividing by 5, 90, 5's going to 450, and 27 5's going to 135. So at this point I've divided by 5, but it's still not in its simplest form. Okay, I can see that they're both at least divisible by 3. Hopefully you can see that. So if I divide both sides by 3, I will get to 30 to 9, and that's still not in its simplest form. So I'm going to divide both again by 3 because they're both still divisible by 3, and that will get me to 10 to 3. Okay, that is in its simplest form. There's no other number. If you use the method where you found your highest common factors of the pairs, your HCF should have been 45. Okay, so if you divided by 45 and got you there too, that's the other way you could have done it. That would work fine. Okay, part D. You've been given 25.6 to 46.4. Both got decimals. Only one decimal, to 10 times multiplying by 10 is enough to get rid of the decimals in both. That will leave you with 256 to 464. And depending, you can either find your highest common factor or you can start dividing by 2. They're both even, so you can divide by 2. If I divide by 2, I'm left with 128 to 232. So that's dividing by 2. Then from there, I'm going to divide by 2 again. They're still even, so divide by 2 again. I get 64 to 116. Still even, so I can know that 2 is at least still a factor. So divide by 2 again. And I'm going to get to 32 to 58. They're still even, so divide by 2 again. Okay, this isn't the quickest way, it's just if you struggle finding the highest common factor. So dividing by 2, you get to 16 to 29. Okay, and that will be its simplest form. So that is your final answer. If you found the highest common factor, you would be dividing by 16. Okay, that was the highest common factor, would be 16, and that would have got you to 16 to 29 as well. So whichever way you did it is fine. They both get you to the same answer. Okay, so that's question 6. Question 7. So 7A. The same thing, you've been asked to write each ratio as a whole number ratio in its simplest form. You need to get rid of the decimals. This time, you might need to multiply by more than 10. So if I multiplied 0.25 by 10, I would only be left with 2.5. So I actually need to multiply both sides by 100 in order to eliminate the decimal. Remember, you've got to do the same things to both sides. So whichever needs the biggest change, that's the one you're going to go for. So I need to multiply both sides by 100. That'll leave me with 25 to 310. Okay, so 25 to 310, depending on which way you decided to do it, depends on how you divide it. So let's go for, they're both definitely divisible by 5, they end in 5s and 0s, so I'm going to divide by 5, see if that gets us to the most simplified version. There's 62, 5's in 310, okay? Use a bus stop method if you need to know how to do that. That leaves me with 5 to 62. That's the simplest form. There's no other common factor between 5 and 62 other than 1. Okay, and that would get us back to 5 to 62. That's your final answer for that one. Part B. You have 1.4 to 0.28. Again, multiplying by 10 would only eliminate the decimal in that one. It would leave you with 2.8 there. So I need to multiply by both sides by 100. That would leave me with 140 to 28. I then need to simplify, okay? I'd assume that most people will divide by 2 first as they're even, so we're going to do that method, and then I'll tell you the highest common factor. Okay, so divide by 2 gets you to 70 to 14. Divide by 2 again, because it's still even, but actually, hopefully you can see they're both divisible by 7, because 7 goes into 70 10 times, 7 goes into 14 twice. Hopefully that was an easy one to spot. And then again, they're divisible by 2, so you're left with 5 to 1. Okay, if you use the method of finding the highest common factor, your highest common factor would have been 28. So you divide both by 28, and you would have got to 5 to 1. You could have carried on dividing by 2 at this point, and you got slightly different, but you would get to 5 to 1 in the end as well. Okay? Part C. So for C, you've got 1.62 to 1.8. Again, you can't multiply by 10. It's not enough to get rid of the decimals on this side, so you have to multiply both sides by 100. That will leave you with 162 to 180. And again, you need to pick here what you divide by. If you start by dividing by 2, you'll get to 81 to 90. And then here, so that was dividing by 2. And then here I can see, actually I know they're both in my 9 times tables. So I'm going to divide both by 9. That gets me 9 to 10. That was divided by 9. And that got me to my answer in its simplest form. Okay, so that was 9 to 10 there. And finally, part D. You have got 4.8 to 11.2. Okay, in this case, multiplying by 10 will be enough to eliminate your decimal. So it'll be 48 to 112. You then need to simplify. You can use your HCF as usual, or you can divide by 2 because they're both even. If you divide by 2, you get 24 to 56. They're still even, so keep dividing by 2. 12 to 28. Still even. 6 to 14. Divided by 2 again there. Still even. Divide by 2 again. You get 3 to 7. Okay, which is the simplest form. If you used your highest common factor, you would have divided by 16. Because that was the HCF of 48 and 112. But your answer will be the same whichever way. 3 to 7. Okay. Okay, so there's more questions to try here, so let me just put that up on a bigger screen for you. So if you could please have a go at question 8 and 9, pause the video, and then return please when you have finished. Okay, so I've put the answers there up on the screen for question 8 and 9, but as usual I'm going to go through them as well to make sure that you understand them fully. So, question 8 says, old computer monitors had a width to height ratio of 4 to 3. So, I'm just going to start by writing that information down. So, for old computers, it was width to height of 4 to 3. That's width to height 4 to 3. Okay, new computers, so over here I'm going to write new. They had a ratio of width to height of 16 to 9. So I've just written out the information the question's given me so far. Then it says to you, is each of these monitors old or new? So we have to apply what we know and apply the ratios we've been given to check if those ratios, if those computer screen inches are old or new. Okay, so let's start with part A. I'll just do a rough sketch. We've got 16.8 here, that's inches, and we've got 12.6 here. Okay, so width to height, we know our ratio is 4 to 3. I'm just going to put in the information that they've given us here. Okay, they've given us 16.8. Sorry, ignore that because that's assuming it was old. First, you just need to put in the ratio you've been given. So it's 16 width to a height of 12.6. Okay? The decimals, we're going to get rid of the decimals so that we can simplify them as we've learnt from the previous examples. So I need to multiply them both by 10 to get rid of my decimals. That leaves me with 168 to 126. Okay? I'm going to simplify them, and then that will help me work out what type of computer screen they are, old or new. Okay? I know they're both divisible by 3. You could have gone for 2. Doesn't matter. We get to the same point. I'm going to divide both sides by 3. That leaves me with 84 to 63. Sorry, divided by 2 first. 84 to 63. From there, I know they're not even anymore. They're both divisible by 3. So I'm going to divide both sides by 3. That gets me to 28 to 21. Okay, that's dividing by 3. Then from there, I can see they're both divisible by 7. Okay, 7 goes into 28 4 times, and it goes into 21 3 times. So that was divided by 7. And that brings me to the ratio for the old computer monitors. Okay, so therefore, remember those 3 dots mean therefore, it is an old monitor. Okay, that's because it's simplified back to the ratio that was for the old monitors. Let's try it with B. With part B, they've given us a computer screen. It's 18.4 by 10.35. Okay, so we're doing width to height. And what we've got from our computer screen is 18.4, that's its width, to its height here of 10.35. Okay, so what we're going to do, we're going to get rid of the decimals first, then simplify, see which ratio it comes back to. As this one's got 2 decimal places, I need to multiply both by 100 to eliminate that, and that's going to leave me with 1,840 to 1,035. Okay, so I need to see how I'm going to simplify that. So I know they both end in 0 or 5, so they're divisible by 5 at least. That's going to be the best place for me to start. So I'm going to say divide by 5. 1,840 divided by 5 is going to be 368. And 1,035 divided by 5 is going to be 207. Now, what's not nice about this one is I've got to a point where I can't really easily see a factor. I can't see an easy one that I can just keep going with as we've done previously. So I am going to have to resort to doing my highest common factors, okay, of both. So just as a little side part over here, I'm going to find my factors of 368. Then I'll find my factors of 207. See what's the highest in both. So 1 and 368 is even, so I know 2 and 184. 3 isn't, 4 is, 4 and 92. And then it keeps going all the way up until you get to 16 and 23. Okay? For 207, you're going to have 1 and 207, 3 and 69, and then 9 and 23. Okay? The highest number in both is 23. 23 is what I'm now going to divide them both by. So if I divide by 23, that gets me to 16 to 9. And here that's dividing by 23. Okay, that was a bit harder, that one. You could have probably used a calculator on that part to help you, okay? So if you did struggle, you can go back, try it again, and you could use a calculator. As it's 16 to 9, we know therefore it's a new screen. Or a new monitor. Okay, because it shares that ratio. It has the same ratio as the new monitors. Okay? So you've got another 2 questions there to try. I'm just going to put that on the big screen for you so you can see. Please pause and then I'll put up the answers, okay? Give it a good go. Pause it and play when you're ready for me to go through the solution. Okay, so solution's up on the screen there. Let me just get my split screen up and I'll go through it. Not working very well though. That's better. And then the camera. Okay, so the answers are there. So for 10 you should have 675 grams, and for 11 you should know he will use 300 grams. But I'll go through that with you now. So for question 10, it says the ratio of chickpeas to broad beans, so chickpeas to broad beans in hummus is 2:9. Jack uses 150 grams of chickpeas, okay? So the chickpeas part, he uses 150. So you need to work out, well, what did he do to get from 2 to 150? He times by 75. So you therefore needed to times 9 by 75, and that would get you to 675. Therefore, he uses 675 grams of the broad beans. Okay? For number 11, the question says, the ratio of okra to sweet potato in a korma recipe is 15 to 8. So okra to sweet potato in a korma recipe is 15 to 8. So just writing down what the information's told me. Raj uses 160 grams of sweet potato. So this is the sweet potato, so this is the 160 part. We need to work out, well, how do you get from 8 to 160? You times by 20. Therefore, I need to times 15 by 20, and that's going to give me 300. Okay? So it said the question, will he use all of the okra? He had 350 grams. No. He will only use 300 grams. Okay? Thank you very much. That's the end of the lesson there. Well done. Hopefully you understood that and join for the next lesson for 11.3 tomorrow. Okay? Thank you very much.